Greetings and welcome to Aviation Safety Risk Management through Hazard Analysis. And in this video, we're going to look at one of the foundational concepts in risk management, and that is the risk framework. So what this video includes is a discussion of how risk frameworks are used for risk analysis. We'll start by looking at how this tool can be used to organize data that we have, or in some cases, identify data that we need. We'll also look at how to develop a severity distribution from our data, and specifically contrast this with the legacy technique of simply choosing one level of severity from a list of categories based largely on intuition. And then we'll start to understand what a likelihood is and how a risk framework can be used to find one. And then we'll move into risk assessment. And although we are going to look at this topic in more detail a little bit later, we'll start off by describing the difference between a likelihood and an expected value. And then we'll start to see how this tool, the risk framework, interfaces with another tool, the risk matrix. Again, more information on that later, but this will give us the first taste of how a risk framework can be used and one of its applications. In this particular presentation, although this is an aviation risk management topic, in order to make the subject matter a little bit easier to digest, I'm going to use a traffic example, a vehicular traffic example, to illustrate the concept because it's much easier for the average person to wrap their heads around. And so here we see it. In the background, you can see kind of a typical intersection between two highways, and you can also see that it's icy. And so this kind of gives us the backdrop for what we're going to talk about. The other thing that you can see are three pieces of information that are generally available to us in any risk assessment that we might undertake. The first one just gives you an idea as to how many vehicles pass through this intersection on a given day. And the framework that we're going to develop is intended to be used in the future to look out at a risk horizon of about 10 years. And so what we're going to do to set the stage for that is to look backwards in time over approximately 10 years. You can also see that we've got some information about, on average, how often this road becomes icy like it is in the picture. And then the last piece of information we have is our track record in terms of safety. How many accidents have we had and how severe were they? So this is a risk framework. It's really, in this particular format, it's just a simple event tree. And what you can see here is that we start off with the hazard, in this case, ice on the roads. And what we're interested in is how often does this hazard occur? And when it does occur, how often does it cause an accident? And then when it causes an accident, how serious are those accidents? And you can see we have the entire spectrum covered near the bottom where there's no injury and no damage, probably the best case scenario. And then at the top, you can see one of the worst cases, or possibly the worst case, that being a fatal injury. So what do we do with this? Well, we start by taking some of the data that we have and simply entering it into our tree. And this is the first step towards understanding the severity distribution, which is kind of a fancy name for just saying to ourselves, over a long period of time, if we have a whole bunch of accidents, how often, on average, would we expect an accident to be fatal or have critical injuries or serious injuries or so on? So by just taking the data we have and sort of making note of it inside this framework, we can now move on to understanding how many total accidents we have. And it's no accident here, forgive the pun, that this winds up being exactly 100 accidents if you add them all together. And the reason for that is to show you how simple it can be to turn this observation of accidents over time into probabilities. And you can see very quickly that rough 7% of the accidents had fatal injuries, 12% had critical injuries or extensive damage, and so forth. So we can just do that simple in our head division to come up with the probability of each one. Notice that these probabilities all add up to 100%, which is sort of a poor man's way of explaining the law of total probability. Something's going to happen, and everything combined that can happen has to add up to 100% at the end. And now we have our first severity distribution. So the next step now is to determine likelihood. Now, in our common vernacular, in our everyday conversations, we generally consider the term likelihood and probability to be the same thing. But in aviation risk management, they are definitely not the same thing. You can see that what we have inside the framework right now are 5 probabilities. These are specifically conditional probabilities, but they are not likelihoods, and we can't use them as likelihoods in risk management. So let's move on and see how we find these likelihoods. The first thing we need to do is we need to take account of our exposure. So what I've done at the bottom is I just took the information above and did a little bit of multiplication so that you can take those 300,000 vehicles per day and see how many there are per year or per 10 years. You can also see that the road ices up 25 times a year. So again, I just multiplied that by 10 to come up with 250 days over 10 years. And then again, through simple multiplication, I found out that there were about 75 million vehicles that pass through this intersection when it's icy. Another way of saying that is those 75 million vehicles out of the 1.1 billion are the ones that are exposed to the hazard. So now what we can do is we can move on, and again, through just some simple division, we can fill out the rest of the conditional probabilities in this framework. You can see that 25 times out of 365 times is roughly 7%, or you can see the more precise number in there, 6.85% of the time is how often this hazard occurs. And then 100 accidents out of the 75 million cars that go through there when it's icy, you can see translates into that conditional probability right under accidents. A very small number, but significant when you look at it over time. And so now we get to the last step, and that is we need to determine the joint probabilities of each one of the possible pathways through this tree. So if we look at the top pathway, for instance, the hazard occurs, it causes an accident, and that accident includes fatal injuries. The joint probability of those 3 things happening together is found by just multiplying them. The 6.85 times the 0.0013 times the 7, and it gives you that number on the far right, 6.39 times 10 to the minus 9. And that's expressed in scientific notation because that is a very small number. And that also is a likelihood. That is essentially a way of defining what a likelihood is in risk management, especially when we're using hazard analysis. It's the probability of a hazard occurring, causing an accident, and that accident reaching some level of severity. So with that, let's move on and understand how we can use this risk framework to perform a risk assessment. So in this depiction, all I've done is taken the risk framework that was on the previous slide, copied it and pasted it onto this slide, but I added one more column. Because experience shows this is one of the more commonly misunderstood concepts in risk assessment. Risk, the term risk and the concept of risk is defined as the combination of a likelihood and a severity. And that information is in this framework, but it's specifically not defined as an expected value and severity. Now, both likelihoods and expected values are incredibly powerful tools, but like any tool, they have to be used correctly in order to be effective. So let's just very quickly explain what an expected value is. And the easiest way I know to do that is to use a simple 6-sided die. So suppose I were to roll a 6-sided die, and I ask you the question, what's the probability of it coming up a 3? Not too hard to figure that out. We just say, look, it's a 1/6 chance of happening, and that would suffice as our probability. But now, what if I asked a different question? What if I ask, if I were to throw this 6-sided die 60 times, on average, how many times would you expect the 3 to show up? And so we just multiply that probability, 1/6 times 60, and we'd say on average, we'd expect it to show up about 10 times. And the same with any other number as well. That's what an expected value is. And one of the more powerful attributes of an expected value is it takes something that appears very complex and intimidating, like 6.85 times 10 to the minus 8, a number that most people aren't comfortable with and don't have a very good intuition about what that means. But if we translate for them and we say that translates into 7.5 accidents per year, now we've got a term that most people can understand very easily. And that's really the difference between the likelihood and the expected value, and you can start to see how each one is used. However, a likelihood could be applied to any one of those vehicles passing through the intersection, whereas that concept really doesn't have any applicability at all when we talk about expected values. So the next step that we're going to look at today is how do we take the information on the screen now and use that to communicate risk through a risk matrix. And this is what that looks like. Just an example of a risk matrix. And again, in subsequent videos, we'll take a much closer look at what a risk matrix is, where does it come from, what are its capabilities, and also what are its limitations. But for now, all you really need to know is that if we take those likelihoods in that column, those 5 different probabilities, we can plug those into the 5 columns in the risk matrix where they belong according to their probability, and it gives you a very complete picture of the risk, as opposed to legacy techniques that you may be familiar with where you'd only expect to see one of these plotted in a risk matrix. So it's just a more complete picture. Anyway, that's it for this particular presentation, and we'll move on to some other topics and circle back to some of these things in a little bit more detail later. But for now, if you want to get in touch with me, feel free to leave comments, or you know the drill with all these YouTube videos, or I've got my email address up there and you can fire off an email as well. Looking forward to any feedback or criticism you might have, and look forward to the next video soon.